don't get it. How they're saying, oh, it's not an impact because it's not there. That doesn't.
There's no river there.
Yeah. So
well,
you'll impact in the river.
You'll have to forgive me for oversimplifying a very lengthy legal process. There are probably more complementary ways to say that. I am being inflammatory by the way that I explain this, and to give everyone due credit, I'm sure that very logical and well-intentioned people did their best in that process. But the fundamental bottom line is this was a clear violation of the Clean Water Act under the previous understanding of the Clean Water Act, and because an executive can reinterpret how they read existing law, it's within every president's power. I'm sure that our liberal superstar presidents have done this to other laws.
Yeah.
I think it is legitimate presidential power to do that. Yeah. Anyway, yes.
Has anything been done to re-change that law?
Well,
are they cleaning up their act?
I believe that even in the Bush administration, that line was negotiated back for the environmental side of it. And then when Barack Obama's EPA was starting to flex its muscles early in his first presidency, they withdrew approvals for mountaintop removal permits, and they stalled all pending mountaintop removal permits until they could set up new guidelines for how to protect rivers.
So this is stopped currently?
This is slowing down big time. It was really easy during the Bush administration, and this exploded during those years. And this has kind of been slowing down for a variety of reasons. The politics of this got soured when people started to get really angry. And there were a couple of famous accidents, too, where there was like giant mudslides that released really gnarly impounded water. You see, look at that. Sorry, I do want to make one more point, but I'm kind of hurrying today. It's a transitional day. We're going to go from 10.1 to 10.3, so I'm kind of like dotting my T's in my eyes or whatever, dashing my eyes. You can see in this photograph one of the big problems with mountaintop removal. When you start playing with drainage, the water's going to come out of the mountain dirty. So you got to contain that water before it's spilled into your city where people are probably drinking that water. And so one of the big challenges of mountaintop removal is this, figuring out how to manage the runoff from those tweaked watersheds. Whenever those dams fail, the flooding and the water pollution have been really big challenges for mountaintop removal projects. Yeah.
Would it be impossible to, like, as you're doing the mountaintop removal, to design some workable watershed?
You know, I first of all have to give credit to people who've made an effort. I'm sure that someone has done this better than the average.
Yeah.
And essentially, I think I have a lot of faith in engineering. We can pretty much solve any problem if we get enough smart people trying. The flip side is we're doing large-scale environmental manipulations. So when things go wrong, the impacts are giant. Yeah. On top of that, if we don't hold people accountable, cheaper is more profitable, so why bother? And so there has to be some massaging of our environmental regulations to be demanding enough that people solve these problems. Yeah. I'm sure that most problems are solvable, but when I look at stuff like this, I like wilderness, and that looks not okay to me. Like, no matter what you can do to fix that drainage or whatever, that just looks like a downer. That doesn't seem right. This is a gut feeling, personal response. No time. All right. So yesterday when you guys went mining in cookies, a lot of you got dirty chocolate chips. How many of you had no clean chips? How many of you got all your chips eaten by Peter?
I need Andy chips.
Oh, dang it. Wait, Michael chips. I did not. Okay, so Tyler. All right. So, that analogy was very carefully timed. I did that lab before this for a reason. Remember, when you were chipping away at your chips, the crumbs stick to the chocolate. And in the baking world, that's pretty obvious. Just like in the geology world, it's pretty obvious that rocks and metal will often stick together. It's called ore. When you get a big crumb of cookie with chocolate in it, you got to figure out how will I separate the valuable chocolate from the worthless cookie crumb. And so please look up. There are three main industrial ways that you need to learn for this class. Smelting, heat leach extraction, and mercury amalgamation. This we have not discussed in class, and I fear that many of you have kind of fallen asleep today. Wednesday seems to be a low-effort day for many of us. Heads up, this is kind of important. Smelting is used only for metals, and when you see that word, you should think of it as melting. You cook the rocks, no, not smoking crack cocaine. I mean, you light the ore on fire. You heat it. Very, very high temperatures. We're talking, uphill of 900, 1,000, up, hot, really hot temperatures.
So it takes a lot of energy.
It takes a ton of energy, which is the main problem. It's expensive. But when you roast the rocks, the metal will melt. So if I'm holding a big rock with a little smear of copper, by getting it really hot, the copper will start to drip out. And then I'll have just the rock and all the molten copper at the bottom. That's exactly the point. The only problem is all that burning of rocks is going to cause a lot of oxidation, which often includes sulfur oxides, because sulfur is really common in our rock. And that, as you know, leads to really gnarly acid rain. This was the primary cause of acid deposition in the United States for most of the industrial era. Yeah.
So then how do you keep the rocks and the metal separated from melting?
There's probably some smart solution that you and I haven't come across. They have different melting points. So I imagine if you put it up on a special screen, the rock would stay on top and the metal could melt through. I don't know. I know that people had solved this issue in really primitive methods way back in the day. Like some of the very first copper mines on Earth, I don't even know how many hundreds of years ago, did this in open fires. They would pile up chunks of coal and then put copper ore on top of the coal and then light it. Yeah, copper and bronze. Yeah, were used first because of their low melting point. So you can probably pull that off with just an open pit fire. Okay. Billows.
I thought that was good off screen.
Don't they do it in clay pots and clay?
You're all smarter than me. So all of your amazing questions are just go ask the pavement. Probably get a bit of an answer. Okay. The second method I want to talk about is called heap leach extraction, and like it sounds, you make a heap and then you leach out the ore. You could either melt the metal and keep the rock, or melt away the rock and then keep your metal. Heap leach extraction, which is usually done for precious metals and to a lesser degree for coal, uses corrosive liquids, often cyanide, but I don't really understand. There's a lot of different types of cyanide. So you use corrosive liquids to dissolve the rock away from the material. Like this, you make a big heap, and then you spray it with the corrosive to leach out the rock. The slurry at the bottom has to be contained. And I got to say something really clearly. If you do this right, I'm not aware of any significant environmental impact. In the theoretical sense, this can be done. But remember, if there is a break-in, a hurricane, an accident, the consequences could be really severe because we're dealing with industrial volumes of corrosive liquids. Yes?
Have you read Collapse, speaking of which?
I have.
They have a whole section on the heat leach extraction mining in Montana.
I did not remember that section at all.
No?
I'm going to skip that.
How they were reporting how that river is forever leaching.
Huh.
Oops, sorry.
Don't remember that. Remember, like I said, you can do this well. The question is, what happens when you do it poorly or when an accident happens? Finally, this is actually something that I think you should know just as citizens of the modern world. There's a method called mercury amalgamation. This is largely illegal in the first world, but it used to be the most common method in the distant past. So if you find an abandoned gold mine from the last century, you'll find a lot of mercury pollution. This was really common. They did this in the Santa Ynez River, so you still can't eat rainbow trout from the upper Santa Ynez River. Coincidentally, that's our drinking water. Just saying.
Wait, how long ago did they talk about that?
No. I believe it may have been the 19th. I would be shocked if it was the 1950s, 60s years. But please look up. This is still used in remote or in secret gold mines. In the tropics, this is the main method. In those illegal tropical gold mines I discussed earlier, this is the leading way of processing gold ore. You mix mercury and gold to make a mechanical blend, like different colors of Play-Doh. Amalgam is not a chemical bond, it's a mechanical blend, like Play-Doh colors. That amalgam is really heavy, so it sinks, making it really easy to separate out the sand and the rock because the amalgam is so heavy. Then the final problem is how to split that blend. You have to use heat and corrosive liquids, often cyanide or acid, nitric acid in particular. And that makes really significant mercury pollution of the type of mercury that goes into the food web. Because it's methylated, exactly, because of the acids or corrosives that split them, now you've bonded the chemicals to the mercury. Exactly. It actually takes it out of the mechanical blend by changing the chemical bond. I want to meet with your mom. Tell her I want to talk to her. I owe her many thanks for her donation. But I'm usually I plan my meetings like a week out. I have a meeting Thursday at lunch and a meeting Thursday after school. On Friday I have this. So I'm available next week pretty much every day after school, like